Usually when we talk about a medical diagnosis, there's this expectation of clinical precision.
Oh, absolutely. Like a very mechanical view of things.
Right. You break your arm, the x-ray shows a jagged white line through the bone, and the doctor just points and says, there it is.
It's comforting, honestly, because it's visible. I mean, we are deeply conditioned to view our health through a purely structural lens.
Yeah, we like our biological problems to be neatly categorized into physical parts, right? Things that can be repaired or replaced or just removed entirely.
Exactly. But then you step into the world of human energy.
And that's where the x-ray machine is completely useless, which is exactly what we're getting into today. So welcome back to the deep dive. We are so incredibly glad you're joining us for this one.
It's a fascinating topic. We are trying to quantify the invisible forces that dictate how we feel every single minute of every single day.
And we're talking about the literal flow of electrons inside you. Because that hidden biological engine, it dictates whether you wake up feeling ready to absolutely conquer the world, or if you feel, well, completely drained before your feet even hit the floor.
We're looking at a biological landscape that operates entirely outside that traditional structural paradigm. We are talking about the mitochondria.
Which, most of us only remember from high school biology as the powerhouse of the cell.
Right, the classic textbook cliche. But we have this incredible source material today, an extensive interview with Dr. Martin Picard, who is a pioneering scientist in mitochondrial psychobiology.
And his work completely shatters that cliche.
It really does. He frames them not just as generic power plants, but as these highly dynamic biological resistors. They literally bridge the gap between our psychological experiences like trauma or stress or even a deep sense of purpose and the microscopic physical reality of ourselves.
Okay, let's unpack this because the findings in this deep dive are paradigm shifting. We're going to look at incontrovertible evidence showing human hair turning white from stress and then, get this, reversing its color in a matter of weeks.
It's mind-blowing.
We're also going to explore how massive chronic diseases like Alzheimer's and diabetes are fundamentally just cellular traffic jams.
Wow, look at the exact mechanisms behind why having a psychological sense of purpose literally changes the physical shape of the cells in your brain.
Which is wild. So to start moving away from viewing the human body as a mechanical car that just needs fuel poured into the tank, that's step one, right?
Right. We have to start viewing it as a dynamic electrical ecosystem. So Picard lays out 3 foundational principles of energy in the human body to ground this whole concept.
Let's hit the first one.
The first principle states that you are the energy flowing through the body.
Which sounds almost esoteric, maybe a bit philosophical, until you look at the raw physics of life and death.
Because if you think about it, the physical matter of a living person and a cadaver on a table in the exact moment of death, it's identical.
Right. The bones, the tissue, the DNA blueprint, none of that has vanished.
Exactly. The only physical difference is the cessation of the energy flow. The physical body is really just the vehicle, the temporary scaffolding.
Right.
If there is no energy flowing through the neural pathways of your brain or pumping through your heart or cascading down your nervous system, the entity we recognize as you is simply not there. The energy flow itself is the defining characteristic of life.
I was actually thinking about this through the lens of a modern computer.
Oh, that's a great way to look at it.
Like you could go out and buy this heavily modified, incredibly expensive laptop. It has a high-end multi-core processor, maximum RAM, a beautiful display. And that represents your genetics, your physical structure, your inherited traits.
Right, all the premium hardware.
But if the battery is depleted, and there is absolutely zero electrical current running across that incredibly advanced motherboard, it is literally just a heavy paperweight.
That analogy maps perfectly onto human biology. The most advanced hardware in the universe means absolutely nothing without the electrical current animating it. And what's fascinating here is how that electrical current is actually generated.
Which brings us back to the mitochondria.
Yes. They are the microscopic components closing that biological circuit. But to really understand their scale, we have to look back roughly 1.5 billion years.
Wait, 1.5 billion years?
Yeah. Mitochondria were originally free-floating, independent, ancient bacteria, specifically an alpha proteobacterium.
So they weren't even part of us initially?
Not at all. They merged with an ancient archaean host cell in this wildly rare evolutionary event called endosymbiosis.
Endosymbiosis, meaning basically our entire cellular structure is a hybrid.
Exactly. The host cell enveloped this little bacterium, but rather than digesting it for a quick meal, they formed a permanent symbiotic relationship.
So what was the trade-off?
Well, the host cell provided a safe harbor and a steady supply of nutrients, and in return, the mitochondria provided a massive, unprecedented upgrade in energy processing.
And that singular event is what allowed multicellular life to evolve.
It changed everything. Fast forward to today, and you have hundreds, sometimes thousands, of these mitochondria inside almost every single cell in your body. We are talking about roughly 5,000 trillion mitochondria operating inside you right now.
That's just, I mean, a number that large almost loses its meaning. 5,000 trillion microscopic engines operating simultaneously.
And their daily function is to act as tiny biological resistors. They basically pull electrons off the carbon bonds of the food you eat.
So, like if I eat an apple.
Right. If you think about a green leaf or an apple, that organic matter is essentially holding solar energy from the sun that was crystallized into molecular bonds.
Okay, that makes sense.
So your mitochondria take those molecules, they rip the electrons off one by one, and they flow them down a microscopic electrical circuit.
Which is known as the electron transport chain, right?
Correct. And they flow those electrons toward the oxygen that you breathe in.
Oh, wow. So the food we consume acts as one pole of the battery, and the oxygen we breathe from the atmosphere acts as the other pole.
You nailed it. That vital flow of electrons moving toward oxygen to create water and heat, that is the fundamental engine of human life. It is literally the reason you are warm to the touch.
Wait, really? That body heat is just the byproduct of this electrical current.
Yes, it's the byproduct of your mitochondria continuously processing this electrical current at a staggering scale.
That is absolutely wild, which I think brings us to Picard's second principle. There is a fixed energy budget.
This is a huge paradigm shift.
Because the modern world heavily markets the idea that consumption equals output. Like if you hit a wall at 2 p.m., the cultural messaging tells you to just, drink an energy drink, eat a protein bar.
Just pour more fuel into the machine.
Right, and you will magically have more energy to burn.
But human biology is constrained by the laws of thermodynamics. Your overall capacity to process energy through those 5,000 trillion mitochondria is relatively fixed on any given day.
So you can't just endlessly overload the biological system with fuel to get infinite output.
You cannot. The internal infrastructure simply cannot process it.
And if you try to force excess fuel into a system with a fixed processing capacity, you don't get more energy, right? You get overheating.
Exactly. You get cellular inflammation.
And that constraint leads directly to principle 3. Life is resistance.
This one is profound. In physics, if energy flows through a medium with absolutely zero resistance, nothing happens.
No work is done.
Exactly. There is no transformation. Like a photon of light traveling through the vacuum of deep space just travels endlessly as light.
Right.
But when that same photon hits a green leaf on Earth, the physical structure of the leaf provides resistance. It stops the photon, captures this energy, and that constraint allows the energy to transform into something new.
Chemical food.
Exactly.
So the human body requires constraint and resistance to grow, adapt, and transform.
We tend to view resistance as a negative, something slowing us down. We do, but without those mitochondrial resistors constraining the electron flow, we couldn't harvest the energy required to build tissues, form memories, or fight off infections.
Okay, so because that energy budget is finite, the body operates under extreme evolutionary pressure to be highly efficient. It kind of functions like a ruthless corporate accountant.
That's a perfect way to put it. It must constantly prioritize where to allocate its limited daily resources. And Picard introduces a framework for this called the cellular Maslow's hierarchy of needs.
Right, so in traditional psychology, Maslow suggests humans must secure basic survival food, water, shelter, before they dedicate energy to self-actualization, art, or philosophy.
And the microscopic cells in your body follow the exact same prioritization protocol.
Immediate survival always trumps long-term flourishing.
Always. If the biological accountant detects a threat, it doesn't care about keeping your skin looking young or keeping your hair perfectly pigmented.
So when a stressor appears, whether that's a physical threat like a predator or an internal threat like a viral infection, what happens to the budget?
The body immediately liquidates energy from other departments. It funnels massive amounts of your daily budget straight into the immune system and the acute stress response mechanisms.
And it steals that energy from where?
From biological processes categorized as growth, maintenance, and repair. So DNA repair enzymes get dialed back, the clearing of cellular debris in the brain slows down, pigment production in hair follicles gets completely paused.
Okay, to quantify just how expensive this stress response is, the source material talks about this incredibly revealing experiment.
Yes, this is fascinating.
They wanted to measure the energetic cost of psychological stress, not running a marathon, but simply preparing for a threat.
So they took human cells in a petri dish and exposed them to the equivalent of cortisol, which is our primary stress hormone. They meticulously tracked the ATP production and the oxygen consumption rate of these isolated cells.
Because the goal was to see the raw metabolic tax of just a perceived threat.
Right. And what they found was that just the cellular preparation for danger, the metabolic shift in response to the cortisol signal, caused the cell's energy expenditure to spike by a massive 60%.
Oh my gosh, a 60% tax on a fixed energy budget. That is a catastrophic reallocation of resources.
It really is. And the crazy part is, your body does not distinguish between the physical threat of a predator in the woods and the psychological threat of a hostile email from your boss.
Or just ruminating over a financial mistake, right?
Exactly. The cortisol floods the system either way. Suddenly, your cells are burning 60% more energy just to maintain a state of high alert while you are simply sitting stationary at a desk.
And to make this concept really visceral, there's this analogy of the 10 soldiers from the source.
I love this analogy.
So imagine your daily fixed energy budget is an army of 10 soldiers. On a pristine, relaxed day, all 10 soldiers are deployed to help you flourish. They are repairing oxidative damage in your DNA, synthesizing collagen for your skin, keeping your cognitive pathways sharp.
Elevating your mood, all of that.
Yeah. But then a stressor arrives. It could be the psychological weight of a failing relationship, or fighting a mild respiratory virus, or even, processing the toxicity of the alcohol you consumed the night before.
The body's threat detection system sounds the alarm.
Right, and the biological accountant immediately reassigns 4 of those 10 soldiers to the frontline defense, the immune and stress response systems.
So you are now left with only 6 soldiers to manage the massive, complex infrastructure of your daily flourishing.
And 6 soldiers simply cannot maintain the entire biological facility, so the body is forced to start rolling brownouts. It shuts down the non-essential grids.
Which perfectly explains the crushing fatigue you feel when you have a mild cold.
Yes. You aren't physically exerting yourself at all. You are lying entirely still in bed. Yet you feel totally drained, deeply unmotivated, and cognitively foggy.
You are experiencing a severe energetic deficit in the conscious sensory systems that make you feel vibrant. You aren't lacking physical calories. Your available energy has simply been forcefully reallocated away from your prefrontal cortex and your skeletal muscles and poured entirely into macrophage activation and immune response.
It makes so much sense when you frame it like that. Now, if that stress becomes a chronic baseline, like if you are waking up every single morning flooded with financial anxiety or relationship trauma, you're effectively operating a 10-soldier facility with a 6-soldier crew for years on end.
And that leads to visible wear and tear.
Which brings us to one of the most visually stunning pieces of research in this deep dive, the reversible gray hair phenomenon.
This completely upends how we think about aging. We have been completely conditioned to view biological aging, particularly hair graying, as a one-way street driven by entropy.
Yeah, the assumption was always that once a hair follicle loses its ability to produce melanin, it's just permanently broken.
But Picard's lab set out to challenge that linear assumption using some incredibly innovative mapping techniques.
Right. They started viewing human hair the same way a dendrochronologist views the rings of a tree trunk.
That's a brilliant way to describe it. A tree ring physically crystallizes the environmental history of that specific year. You can see the dark, thin bands of a brutal drought, or the wide bands of a prosperous rainy season.
And hair functions as a physical timeline of your metabolic history. As the hair shaft is extruded from the follicle millimeter by millimeter, it crystallizes the exact energetic state of your body at that specific moment in time.
It's forensic biology. If you consumed a specific compound 6 months ago, forensic scientists can find its chemical signature at the exact millimeter on the hair shaft that corresponds to that week of growth.
That's wild. So the researchers put out a public call asking individuals to mail in unique hair samples, specifically hairs that displayed 2 distinct colors.
And they received these Ziploc bags full of biological evidence. They placed these hairs under high-powered scanning electron microscopes and used mass spectrometry to analyze the pigmentation patterns.
And what they found was hairs that were dark at the tip, meaning the oldest segment of the hair that grew months ago was perfectly healthy and pigmented. Then, the middle of the hair shaft was completely white, indicating a period where the follicle entirely ceased melanin production.
But the stunning discovery was at the root, the newest growth.
It was dark again.
Yes, the biological aging process had completely reversed itself on a microscopic scale.
Okay, but to understand the specific triggers, they had to map the growth timeline of these hairs against the lived psychological experiences of the donors, right?
Right. They asked participants to graph their daily stress levels over the previous year on a quantitative scale, and they shared this fascinating breakdown of a young woman in the study.
Tell me about this, because this blew my mind.
So they found a single hair of hers that was dark, transitioned to completely white for about 2 centimeters, and then returned to dark pigment. When they calculated the growth rate of human hair, roughly 1 centimeter per month, they pinpointed the exact weeks that the white segment was produced.
And then they laid that biological timeline directly over her psychological stress graph.
Exactly. And the 2 centimeter white segment mapped flawlessly onto a brutally stressful 2-month window in her life.
What was going on with her?
She was finalizing her PhD thesis, navigating a romantic breakup, dealing with severe family conflict, and moving internationally.
Her biological 10-soldier army was entirely decimated by psychological stress. So the hair follicle, which sits extremely low on the cellular Maslow's hierarchy, had its energetic funding completely slashed.
It just couldn't afford to run the melanocytes to produce pigment. But the moment she defended her thesis, the conflict resolved and she settled into her new life, her stress plummeted.
And within days of that psychological resolution, the biological accountant freed up the energy budget, refunded the follicle, and it instantly resumed producing dark pigment.
The researchers actually developed a mathematical threshold model to explain the mechanics of this reversal. It relies on the concept of allosteric load and mitochondrial efficiency.
How does that model work?
Imagine the health of a single cell as a massive ship slowly taking on water. As chronic stress restricts the energy budget, the hair follicle accumulates minor oxidative damage. Its engines become slightly less efficient.
The ship is sinking lower into the water.
Right, but to the naked eye, everything looks fine. The hair is still dark.
Because it hasn't crossed the critical threshold. It's struggling, but still functional.
Correct. But there is a definitive binary threshold. Once the cumulative inefficiency pushes the cell below that invisible waterline, the melanin production mechanisms fail entirely.
The hair flips from dark to white instantly.
Exactly. However, if the cell is hovering just slightly below that threshold and the systemic stress is suddenly removed, the freed up energy allows the cell to repair just enough damage to rise back above the waterline.
It's amazing. And, the interviewer in the source material actually found some of these reversible hairs on his own head.
I remember that part, yeah.
When they mapped his hair's timeline, the return of his natural pigment aligned perfectly with a 2-week cycling vacation he took. He was sleeping 8 hours a night, moving his body consistently, entirely disconnected from his email, and radically reducing his cortisol.
That 2-week drop in psychological friction literally unaged his biology.
But there is a critical caveat to this mathematical model, right?
There is. This reversal requires cellular plasticity. If a follicle crossed the graying threshold a decade ago, it hasn't just stopped making pigment. It has continued to accumulate microscopic damage, sinking deeper and deeper below the waterline.
So a 2-week vacation cannot rescue a cell that is miles below the threshold?
Sadly, no. The window for reversal exists only while the cell remains near that boundary line.
Now, there's a detail from the microscopic analysis of those white hairs that is profoundly counterintuitive. When they looked at the white, stressed-out segments, you would logically assume those cells were dormant, dying, or depleted of machinery.
But the mass spectrometry revealed something else entirely. The white hairs actually contain significantly more mitochondria than the healthy dark hairs.
Wait, really? More mitochondria in the gray hair? That doesn't make sense.
It sounds backward, but that finding cuts to the core of how biological systems react to failure. When a cell experiences stress and its energy processing becomes inefficient, it does not passively accept defeat.
It panics.
Exactly. The nucleus senses the drop in ATP production and attempts to forcefully compensate by triggering mitochondrial biogenesis. It desperately builds more engines to try and meet the energy demand.
So it's the biological equivalent of a failing factory. The machinery on the assembly line is broken and inefficient, so instead of fixing the machines, the panicked manager just keeps hiring more and more exhausted workers, cramming them onto the factory floor.
That is a brilliant analogy, and they aren't hitting the quota, they're just bumping into each other, creating massive friction and wasting huge amounts of resources.
Creating more flawed mitochondria in a highly stressed environment doesn't solve the energy deficit, it just exacerbates it.
Precisely. These inefficient engines start leaking electrons, generating massive amounts of reactive oxygen species, free radicals that damage the surrounding cellular infrastructure.
And this chaotic, inefficient state is what Picard defines as energy resistance.
Yes. And if energy resistance can turn a hair gray, we really have to look at how this mechanism scales up to the systemic failures that actually threaten our lives.
Because the source material uses this exact lens of energy resistance to completely redefine some of the most pervasive chronic diseases of the modern era, starting with diabetes.
The traditional clinical view of type 2 diabetes is heavily symptom-focused. We test the blood, we see chronically high glucose levels, and we conclude the problem is simply that the patient is eating too much sugar.
But Picard's framework reframes diabetes as fundamentally a disease of severe energy resistance.
Yes, let's think of your cellular metabolism like a massive hydroelectric dam.
Okay, I like this.
The water flowing smoothly through the turbines represents electrons flowing through your mitochondria to power your movement. Flowing water creates healthy power.
Right.
But if you shut down the turbines, meaning you are sitting completely sedentary for 14 hours a day, and you simultaneously keep flooding the reservoir with water by consuming highly processed, glucose-dense foods, you create an incredibly dangerous physics problem.
Because the pressure behind the dam builds exponentially. The electrons from the massive influx of glucose are being forced into a system that has zero demand for them.
The mitochondria are overwhelmed by the flow. They cannot process the electrons fast enough, and the system begins to biologically overheat.
And if the system is overwhelmed with electrons, but the person is sedentary, those electrons have nowhere to go. They just start damaging the cell structures. So, wait, insulin resistance isn't the body being broken, it's a deliberate defense mechanism.
That is the exact mechanism. A healthy skeletal muscle cell displays insulin receptors on its surface. Insulin acts as the chemical key to unlock the GLUT4 transporters, allowing glucose to flow from the blood into the cell.
But when the cell is in crisis,
When the cell's internal mitochondria are drowning in excess electrons and suffering severe oxidative damage from the backup, the cell makes a brilliant, desperate survival calculation. It actively internalizes its insulin receptors.
it literally rips the keyholes out of the doors to stop the flood.
Yes, the cell saves itself from immediate destruction by refusing the energy. But that creates a massive systemic crisis. The glucose has nowhere to go, so it backs up into the bloodstream. Blood sugar spikes to toxic levels.
And the body, recognizing that high blood sugar will destroy blood vessels and organs, scrambles for an emergency bailout.
It starts forcibly converting that toxic excess glucose into ectopic fat, specifically visceral adipose tissue around the organs.
Meaning the expanding belly fat and the high blood sugar are just the visible symptoms. The root cause is the microscopic energy resistance at the mitochondrial level.
Exactly.
That reframing makes the body look incredibly intelligent rather than broken. And the implications become even more intense when the source material applies this lens to cancer.
This is where it gets really dark but fascinating. A cancer cell takes this cellular survival mechanism and pushes it into a full biological mutiny.
Because in a healthy human body, the 37 trillion cells operate under a strict social contract, right?
Yes. They constantly communicate and sacrifice for the survival of the whole organism. And the mitochondria act as the ultimate enforcers of this contract.
So,
If a healthy cell accumulates too much DNA damage or becomes dangerously mutated, the mitochondria initiate a process called apoptosis. They release a protein called cytochrome C, which triggers a controlled, programmed cell death.
the cell systematically dismantles itself to prevent a tumor from forming.
Right. The mitochondria hold the biological launch keys. They have absolute veto power over the life and death of the cell for the good of the collective.
So what does a cancer cell do?
Cancer cells survive by disarming that exact mechanism. They engage in a metabolic phenomenon known as the Warburg effect.
Okay, what is that?
Even when they are surrounded by plenty of oxygen, which would normally allow them to generate massive amounts of energy cleanly through the mitochondria, cancer cells actively shut their mitochondria down.
Wait, they turn them off.
They revert to an ancient, incredibly inefficient form of energy production called anaerobic glycolysis.
They intentionally choose a less efficient power source. Why would a rapidly growing tumor want less efficient energy?
Because by shutting down the mitochondria, they eliminate the enforcers. They remove the self-destruct button.
Oh, yeah?
They immunize themselves against the apoptosis veto. They break the social contract and revert to the behavior of a primitive, single-celled organism whose only goal is selfish replication.
That is insidious.
Furthermore, anaerobic glycolysis doesn't fully break down the carbon from glucose. It leaves building blocks available that the cancer cell uses to rapidly synthesize new biomass to divide and conquer.
And because that primitive energy system is so weak, producing only a fraction of the ATP, that a healthy mitochondrion within the cancer cell becomes ravenously hungry.
It requires staggering amounts of glucose just to survive. It even releases chemical signals like VEGF to trigger angiogenesis, forcing the body to build brand new blood vessels directly into the tumor.
Just siphoning massive amounts of the body's energy budget away from healthy tissue.
It is the ultimate manifestation of energy resistance and metabolic rebellion. And researchers are now seeing this exact same pattern of energetic crisis unfolding in the human brain.
Which brings us to the changing narrative around Alzheimer's disease. For decades, the dominant medical theory for Alzheimer's focused entirely on amyloid plaques, right?
Right, these sticky structural protein buildups that form between neurons. The entire pharmaceutical industry chased drugs to clear these plaques.
The source material highlights a massive, glaring contradiction in that theory.
Advanced post-mortem neuroimaging and brain bank studies revealed a shocking disconnect. You can examine the brain of a patient in their 80s who suffered from severe late-stage Alzheimer's dementia and find virtually zero amyloid plaque deposits.
Wait, really? No plaques at all?
No. And conversely, you can examine the brain of someone who died with perfectly intact memory and radar-sharp cognition and find their brain tissue absolutely riddled with amyloid plaques.
So the structural symptom does not reliably correlate with the cognitive decline. If the physical plaques aren't the primary driver of the memory loss, what is causing the brain to fail?
The paradigm is shifting rapidly toward viewing Alzheimer's as an energetic processing disorder, what many researchers now call type 3 diabetes.
Because the brain is an absolute energy hog, right? It accounts for about 2% of our total body weight, but demands 20% of our total daily energy budget.
Exactly. If energy resistance begins to build in the neural pathways, the consequences are catastrophic. The progression mirrors what we discussed with the hair follicle and the muscle cell.
So how does it start?
Long before the severe memory loss manifests, functional MRI scans observe a phase of hypermetabolism in specific brain regions.
Meaning the neural circuits are experiencing intense friction. The mitochondria are struggling to flow the electrons smoothly.
So the brain tries to compensate by aggressively burning more energy, working overtime just to maintain baseline cognitive function.
That's like the failing factory again.
Yes. This desperate overactivity creates massive amounts of oxidative stress and triggers neuroinflammation. The glial cells, the immune cells of the brain, rush in to try and manage the damage, which drains even more energy from the local budget.
It creates a self-amplifying death spiral. The brain exhausts its energy reserves trying to fix the friction.
And eventually, the biological infrastructure burns out completely. The hypermetabolic regions crash into severe hypometabolism. The neurons become highly resistant to insulin. They can no longer absorb glucose from the blood.
And without ATP to power the firing of synapses, form new memory pathways, or regulate mood, the brain regions simply go dark.
That energetic blackout is the cognitive decline we experience as dementia.
This theory is powerfully supported by anthropological research, too. The source material references the Hadza people, a modern hunter-gatherer tribe in Tanzania.
And among the Hadza, Alzheimer's and metabolic dementia are practically non-existent.
Why is that?
They are engaged in a constant, low-level physical movement throughout the day, ensuring a continuous, smooth flow of electrons. They are not flooding their systems with hyper-processed, dense sugars. Their cellular environment maintains incredibly low energy resistance throughout their entire lifespan.
It strongly indicts the modern lifestyle. Sedentary behavior, coupled with a massive influx of refined energy, it's the primary engine of this cellular friction.
It really is. But this energetic framework doesn't just apply to long-term neurodegeneration. It explains acute day-to-day mental health crises through the emerging field of metabolic psychiatry.
This part is fascinating. Metabolic psychiatry views acute mental illness, severe anxiety, crushing depression, not just as chemical imbalances in neurotransmitters, but as real-time energetic disorders of the brain.
And the study they highlight to prove the physiological cost of social stress is absolutely wild.
Yes, the mock trial study.
So researchers brought healthy subjects into a clinical lab, hooked them up to intravenous lines for real-time blood monitoring, and established a calm, relaxed baseline.
All right.
Then they initiated the Trier social stress test. A stern study coordinator abruptly enters the room and tells the subject, "You have been accused of shoplifting by a security guard at a mall."
Which is just, I mean, instantly terrifying.
Right, and they continue, "You are going to face a panel of judges in exactly 2 minutes. You must verbally defend yourself on camera, and your performance will be heavily scrutinized."
The subjects are completely immobilized in a chair. They aren't running, fighting, or doing anything physically demanding. They are entirely trapped in their own minds, anticipating brutal social judgment.
And as the subjects began their defense in front of an unsmiling, hostile panel, their internal physiology went to war. The researchers were tracking a very specific protein biomarker in the blood known as GDF-15.
What is the biological function of GDF-15? Why does the body produce it?
GDF-15 is essentially a cellular distress flare. It is secreted by mitochondria when they are experiencing severe friction and failing to flow energy smoothly.
It's like an SOS signal.
Exactly. It is highly elevated in patients with advanced cancer, severe heart disease, and unmanaged diabetes. It is the biological signal that the energy system is under extreme duress.
And during this mock trial?
The purely psychological trauma of social judgment caused the subject's cells to instantly flood their bloodstreams with massive spikes of GDF-15.
Oh, wow. The psychological terror created the exact same cellular distress signal as a massive physical disease.
Yes, but the mechanism of how that protein actually changes our behavior is what really blew my mind.
Because GDF-15 doesn't just float harmlessly in the blood. It travels up the circulatory system, crosses the blood-brain barrier, and binds to specific receptors located in the brainstem.
Specifically, it targets the area postrema, which is deeply integrated into the brain's nausea and vomiting centers.
So the brain detects this massive influx of distress signals from the mitochondria and makes a rapid evolutionary calculation. Our cells are in critical condition. We are energetically starving or dying.
And in response, the brain initiates a mandatory biological lockdown called sickness behavior.
Sickness behavior, that sounds intense.
It's an evolutionary survival tactic. The brain deliberately shuts down the dopaminergic pathways responsible for motivation and pleasure. It induces feelings of deep lethargy, nausea, and physical heaviness.
It literally forces you to withdraw socially, curl up in a dark room, and stop moving.
The goal is to aggressively conserve every remaining molecule of ATP, so the immune system has enough energy to fight off whatever invisible pathogen is causing the cellular distress.
This fundamentally explains why a week of relentless psychological stress at work physically destroys you. You spend 5 days navigating toxic office politics, stressing over deadlines, and absorbing emotional friction.
And by Friday night, you feel like you've been hit by a truck.
Yes, your joints ache, you feel nauseous, you have zero desire to see your friends, and you literally feel like you're coming down with the flu. It is not a metaphor. Your psychological stress generated real GDF-15, which physically hijacked your brainstem and forced you into a physiological lockdown.
Chronic psychological stress actively mimics severe physical starvation or systemic infection at the cellular level. If your nervous system is trapped in a constant state of high alert, your brain is perpetually receiving chemical demands to suppress your motivation and hoard your energy.
Okay, so if the modern world is designed to continuously trigger these massive stress cascades, and we are working with a strictly capped daily energy budget, how do we actually fix the flow?
That's the million-dollar question.
Because the cultural instinct is just to consume more ways. Drink a third cup of coffee, eat a sugary snack. But we just established that pouring more energy into a resistant system causes a catastrophic backup.
Right, adding more cars to a heavily congested highway does not resolve the traffic jam. It gridlocks the entire city.
The solution is not increasing the volume of energy input. The solution is expanding the capacity of the infrastructure. You have to physically build more lanes on the highway to reduce the friction.
Which totally shifts how we need to view physical exercise.
Yeah, I always viewed the treadmill as a math equation. I burn 300 calories so I can eat a 300-calorie muffin.
A lot of people do. But the biological magic of exercise has nothing to do with what happens while you are sweating.
Wait, really?
During the actual workout, you are intentionally inducing severe acute energy resistance. You are demanding massive amounts of rapid ATP from your skeletal muscles. Your existing mitochondrial network struggles to keep up with the intense demand.
So you produce lactic acid, you generate reactive oxygen species, and you cause micro tears in the muscle fibers. The workout itself is a highly destructive, stressful event.
The adaptation happens entirely in the recovery phase. When you finish the workout and enter a state of rest, The biological accountant assesses the damage.
And it realizes the current infrastructure was completely inadequate to handle the energetic demands you just placed on it.
Exactly. So, to prevent that dangerous level of friction from happening again, it activates genetic pathways like PGC1 alpha to physically build brand new mitochondria.
It expands the mitochondrial network in your muscle tissue and your cardiovascular system.
This is called mitochondrial biogenesis. Because you now possess a larger, more robust engine, the baseline demands of your daily life, climbing a flight of stairs, recovering from a spike of cortisol after a stressful meeting, feel completely effortless.
Your overall capacity to process electrons without generating friction has massively increased.
Exercise builds the infrastructure. But what about diet?
The source material highlights fasting and the production of ketones as primary tools for optimizing mitochondrial efficiency. How do those interventions change the cellular physics?
Well, fasting induces a biological house cleaning process known as mitophagy. A single cell might contain thousands of mitochondria, but over time, due to oxidative damage, some of those engines become clunky and inefficient.
And if you are constantly snacking from the moment you wake up to the moment you go to bed, the cell is never under any resource pressure, right?
Right. It allows those lazy, broken mitochondria to stick around and leak free radicals.
But when you initiate a fast, you intentionally restrict the energy input. The cell senses a potential famine. It immediately shifts from a state of growth into a state of extreme metabolic efficiency.
The cell deploys specialized structures called autophagosomes that hunt down the most damaged, inefficient mitochondria.
They literally engulf them, dissolve them down to their basic amino acids and lipids, and recycle those raw materials to build fresh, highly efficient engines.
Fasting forcefully prunes the biological deadweight.
And as the fast deepens, the body begins breaking down its own stored fat for fuel. The liver takes those fatty acids and converts them into ketones, specifically beta-hydroxybutyrate.
And the source material describes ketones as offering a shorter path for the brain's energy production.
How does that work compared to glucose?
Glucose is a complex molecule. Processing it through the electron transport chain requires multiple intricate steps and enzymes, which creates multiple opportunities for electron leakage and oxidative friction.
But ketones?
The biochemical structure of a ketone allows it to bypass several of those initial steps, specifically complex I of the respiratory chain. It feeds directly into the downstream machinery.
It is a fundamentally cleaner, more direct fuel source. It generates significantly fewer reactive oxygen species while producing vast amounts of ATP.
This is the physiological mechanism behind why so many people who practice intermittent fasting or adopt a ketogenic diet report a sudden, massive clearing of brain fog.
They aren't consuming more energy. They have simply switched to a premium, low-friction fuel. And the brain translates that smooth, energetic flow into a sensation of intense mental clarity.
We also have to examine how external environmental inputs can manipulate the cellular machinery. The source material dives into photobiomodulation, commonly known as red light therapy.
Red light panels have exploded in popularity. People are buying masks, full-body beds, and strange helmets. It's easy to dismiss it as a wellness fad, but there is deep peer-reviewed physics happening when that specific wavelength of light hits human tissue, right?
Absolutely. Visible light usually bounces off our skin, but near-infrared and deep red wavelengths possess a unique physical property. They can penetrate deeply through layers of skin, fat, muscle, and even through the cranial bone directly into the brain tissue.
Wow.
Inside our mitochondria, there is a specific enzyme complex called cytochrome C oxidase.
Complex for the electron transport chain.
Exactly. Cytochrome C oxidase contains copper centers that act exactly like microscopic antennas. They are biologically tuned to absorb the exact photon frequency of near-infrared light.
And what happens when they absorb it?
When those photons strike the enzyme, they excite the electrons, essentially acting as a molecular catalyst. It physically accelerates the speed at which electrons are pulled through the mitochondrial circuit.
It aggressively reduces the internal resistance. They mentioned a clinical trial where researchers continuously shined red light on the subjects' backs while having them consume a massive bolus of liquid glucose.
And the results were incredible.
The red light intervention actually blunted the ensuing blood sugar spike. The accelerated mitochondrial engines processed the wave of electrons so rapidly that the glucose didn't have a chance to back up and pool in the bloodstream.
It's a powerful tool.
But if red light accelerates the engines that effectively, the natural human instinct is to maximize the dose. I should just buy a near-infrared sleeping bag and live inside it 24 hours a day to become superhuman.
And that instinct directly violates one of the most immutable laws of biology, the biphasic dose response, often referred to as hormesis, or the biological bell curve.
Meaning more is rarely better. Optimal is better.
Exactly. A small dose of red light provides a gentle, healthy stressor. It accelerates the electron flow, generates a tiny, manageable burst of reactive oxygen species, and signals the cell to adapt and build stronger internal antioxidant defenses.
You climb the left side of the bell curve to peak optimization.
But if you bypass that peak, if you subject your cells to high-intensity red light for hours on end, you completely overwhelm the system.
The excessive photon absorption hyperaccelerates the electron transport chain beyond its physical capacity.
The mitochondria throw off catastrophic amounts of oxidative stress, completely depleting the cell's antioxidant reserves. The cell panics, shuts down ATP production entirely to stop the fire, and if the damage is severe enough, it will trigger apoptosis and kill itself.
Biological constraint and moderation are non-negotiable.
Yep.
Okay, we have spent this entire deep dive mapping the biochemistry of human energy, the physics of electrons, the pathology of diabetes and Alzheimer's, the biohacks of fasting and light therapy. But we have to transition to the final and arguably most profound dimension of Dr. Picard's research,
The energetics of human purpose.
because he proves that our psychological state is not just an ethereal mood floating in our consciousness. It physically sculpts the cellular machinery in our brains.
This represents the bleeding edge of mitochondrial psychobiology. The most compelling evidence comes from the Chicago Brain Study, a massive longitudinal research project.
Tell me about this study.
For years, psychologists meticulously tracked a large cohort of elderly individuals. They conducted rigorous, recurring evaluations, quantifying their sense of life purpose, their psychological resilience, and their belief that their daily actions contributed to something deeply meaningful.
So they weren't just asking if they were happy, they were measuring their psychological coherence.
Right. And when these individuals eventually passed away, the researchers didn't just file away the psychological surveys. They extracted the brains post-mortem and put the physical tissue under electron microscopes.
They specifically targeted the dorsal prefrontal cortex, which is the neural command center for complex executive function, long-term planning, and emotional regulation.
And the biological analysis revealed a stunning direct correlation. The individuals who scored in the highest percentiles for a sustained sense of life purpose possessed physically distinct, highly adapted mitochondria in their prefrontal cortexes compared to those who lacked purpose.
The structural density of the mitochondrial cristae and the folded inner membranes, where the electron transport chain actually lives, was vastly superior. Their cellular engines had significantly lower energetic resistance.
Having a profound psychological reason to live literally built more efficient biological engines in their brains.
It forces us to confront a massive bidirectional feedback loop. Does possessing highly efficient, low-friction mitochondria naturally generate a psychological state of optimism and purpose?
Or does the conscious psychological choice to pursue a meaningful goal physically reach down into the microscopic level and command your cells to rewire their architecture for maximum efficiency?
The animal model strongly suggests that the command flows in both directions. You can subject a mouse to relentless environmental stress, and its mitochondrial networks will physically fragment and degrade.
But you can also chemically optimize a mouse's mitochondria, and it will immediately display highly confident, resilient, and socially dominant behaviors.
Your mind sculpts your biology, and your biological engine dictates the boundaries of your mind.
Dr. Picard used an analogy in the source material to explain how psychological purpose physically alters energetic flow, and it is brilliant.
Hear it.
He asks us to visualize a standard 60-watt incandescent light bulb. It is constantly radiating 60 watts of raw power, but that energy is completely diffused. The photons are scattering chaotically in a billion different directions.
They bounce off the walls, they bump into each other, and they dissipate rapidly.
That is the definition of incoherent energy. It illuminates a small area, but it lacks the structural alignment to do any meaningful, concentrated work.
Exactly. Now take that exact same quantity of energy, 60 watts, but run it through a focusing mechanism. Align the waveform of every single photon so they are moving perfectly in phase in the exact same direction without interfering with one another.
You have transformed the incandescent bulb into a laser beam.
And a 60-watt laser possesses enough coherent energetic force to cut straight through solid steel.
That physical transformation perfectly mirrors human consciousness. When we are constantly distracted, endlessly scrolling through social media, ruminating over past slights, and worrying about 10 different trivial anxieties, Our internal energy budget acts exactly like the incandescent bulb.
Our cellular energy is completely diffused and scattered. We burn through our entire daily budget. We feel completely exhausted by 5 p.m., but we haven't actually moved the needle on anything meaningful.
But a deep sense of purpose acts as the ultimate psychological focusing lens. It takes your scattered, chaotic biological energy and aligns it into a coherent laser beam. The friction drops to zero because all systems are pulling in the exact same direction.
This maps perfectly onto an anecdote from the source material about Steve Jobs. Kevin O'Leary from Shark Tank was discussing his experience working directly with Jobs back in the 1990s.
O'Leary observed that Jobs operated his entire life on a ruthless 80-20 signal-to-noise ratio.
The signal represents the vital, coherent goals that actually move the mission forward, and the noise is the infinite array of daily distractions, social obligations, and irrelevant problems.
O'Leary noted that Jobs would wake up every morning and identified the 3 to 5 specific actions that absolutely had to happen that day to advance his vision.
He would pursue those core objectives with terrifying absolute focus. Everything else, emails, administrative tasks, even incredibly good ideas from his engineers that didn't align with the primary mission, was ruthlessly ignored.
His biological and psychological energy was 80% pure, coherent signal. And that extreme level of internal coherence radiates outward. The software engineers at Apple famously referred to this phenomenon as Jobs' reality distortion field.
It wasn't just a metaphor for his charisma. It was an energetic reality. An engineer would tell Jobs that writing a piece of code would take 6 months. Jobs would lock eyes with them, channel that absolute laser-like coherence, and tell them they could do it in 2 weeks.
And because his internal energetic conviction was so completely devoid of friction or doubt, it would literally entrain the nervous systems of the people around him.
He would pull their diffused, anxious energy into his laser beam, and they would consistently accomplish the impossible.
It relies on the physics principle of resonance. If you strike a tuning fork so it vibrates with immense coherent force, and you bring it in close proximity to a stationary tuning fork, the sound waves will force the second fork to begin vibrating at the exact same frequency.
A human being operating with absolute laser-like purpose acts as a massive biological resonator. They reduce the energetic friction in everyone they interact with.
Applying this to the listener trying to navigate a normal, chaotic Tuesday changes everything.
Setting fierce boundaries, saying no to superficial obligations, and pouring your focus into a goal that actually matters to you is not just a self-help productivity hack. It is a profound, measurable biological intervention.
By engineering coherence in your daily schedule, you literally reduce the microscopic mitochondrial friction inside your cells. You cure the energetic diffusion that is making you feel so exhausted.
But it requires cultivating a heightened state of internal awareness, right? What Picard calls mitoception.
Yes, mitoception. We have to discard the industrial view of the human body as a combustion engine, where we can just pour caffeine and sugar into the tank and force the gears to turn.
We must learn to tune in to the microscopic friction. We have to notice when a specific habit, a toxic environment, or a fragmented schedule is causing our 5,000 trillion cellular engines to scatter and diffuse their power.
Cultivating the sensitivity to feel the flow of those 5,000 trillion engines. Knowing intuitively when your system has the capacity to push hard and expand the biological highway, and knowing when your energetic budget is constrained and demands deep restorative rest.
We have covered an immense amount of scientific ground in this deep dive. We started with the profound realization that we are not our physical hardware. We are the electrical energy flowing through it. We mapped the strict internal accounting of our finite daily energy budget.
We examined how chronic, relentless resistance, whether driven by a sedentary body flooded with refined glucose or a brain flooded with relentless psychological anxiety, causes the cellular machinery to overheat, triggering the biological lockdowns that drive diabetes, cancer, and cognitive decline.
We looked at the awe-inspiring plasticity of biology, how a single hair follicle can physically unage and restore its natural pigment within days of a stressor being removed. And we outlined the physical and psychological tools to optimize our internal flow, replacing consumption with efficiency through fasting, movement, and the radical coherence of deep purpose.
It's an incredible shift in perspective.
I want to leave you with one final lingering thought to chew on as you go about your week. We established that purely mental stress, just the psychological anticipation of being judged or falling behind, causes your cells to secrete massive amounts of the distress protein GDF-15.
That protein physically invades your brainstem and tricks your nervous system into believing you are starving or severely infected, forcing you into a state of deep physiological exhaustion to conserve energy.
So if purely mental stress creates authentic biological starvation signals, we have to look at our modern environment. The relentless 247 barrage of digital notifications, the curated outrage of the news cycle, the infinite social media comparisons. Are these technologies effectively tricking our mitochondrial networks into a permanent, lifelong state of energetic hibernation?
And if that is the biological reality, is simply putting your smartphone on Do Not Disturb actually the most profound, immediate medical intervention you can perform for your cellular health today?
It demands that we ask whether we possess the discipline to aggressively silence the noise so that our biology can finally resonate with the signal. Because right now, on paper, you might look perfectly fine. Your medical chart might